The genetic improvement of crops has been a tremendous advancement in improving society through technology. Our ancestors 7,000 to 9,000 years ago domesticated what appeared to be small rocks into the large ear of maize we see today. And as a maize breeder, I feel particularly well suited to explain the rest of these improvements. So from this, regional heirlooms were developed throughout the Mesoamerica, where farmers would select just individual ears they thought best, with little improvement in gain or scientific processes. Throughout the 1930s up till today, the phenotypic and scientific breeding approaches have been to use automated harvesters to collect more information about each individual, use more locations to collect genetic by environmental information, utilize off-season nurseries to get in multiple cycles per year, and of course use advanced statistics to predict what the best variety is out of all this information. In the late 1990s, there was some ideas that individual genes would be able to be manipulated to dramatically improve crops, which largely hasn't been bore out. What has been bore out is small quantitative improvements through tools like genomic selection, where random markers throughout the genome are used to monitor and assign value to individuals, which can be used for predictive and anticipatory selection of the best individuals. Now, how are we going to use this information in the future? Well, I think we can build on this through unoccupied aerial systems, which allow us to collect four-dimensional phenotypic information on genotypes, which include the dimension of time. So for instance, we can look at plant growth curves showing a number of different varieties here in the bottom left-hand corner over the growth season. We can also incorporate additional value rather than just yield, such as nutrition or ecosystem service provision. To use these determinant variables, or independent variables, we can use a number of predictors such as genotypic SNP information, various height measurements that we know to be physiologically important, or most excitingly, random phenotypic measurements collected from the UAVs, much in the same way that random genomic markers are used in genomic selection. These can be incorporated into a relationship matrix, and through crop modeling, statistics, including artificial intelligence, spatial analysis, and temporal analysis, the best and most promising varieties can be predicted and selected faster. I don't think we need to limit ourselves to existing crops, though. When we think about what our ancestors didn't manage to domesticate, it's perennial wild relatives such as Zea diploperennis, which photosynthesizes throughout the growing season or throughout the entire year, and its roots stay alive, sequestering carbon, feeding microbes, and retaining soil. Unlike the annual species, which is completely senescent and leaves bare soil. So if we could focus more on improving perennial grain crops, farmers might benefit and the environment might benefit.